Welcome to this explainer. Today, we're diving into a truly incredible story of human potential. We're going to look at exactly how Dr. Andrew Huberman used the clinical science of neuroplasticity to completely transform his life. I mean, we're talking about a guy who went from being a troubled, parentless youth to becoming a highly respected Stanford medical neuroscientist. And we'll be breaking down the exact biological mechanisms that make such a drastic reinvention possible for literally any of us. Okay, just picture this jarring reality for a second. Long before he was a polished Stanford professor getting published in top-tier journals like Nature, Huberman was navigating the chaotic 1990s skateboarding scene as a completely parentless teenager. His parents split up when he was just 13, his mother struggled with severe depression, and he essentially just joined a pack of truant kids roaming around San Francisco. He literally describes himself during this era as totally feral. Part 1. The Feral Skateboarding Years. We are going to use Huberman's personal timeline as a sort of narrative spine today, really deconstructing the exact clinical neuroscience behind what was happening in his brain back then. Because understanding that descent into chaos is the absolute key to understanding his ultimate biological mastery. Just look at the sheer cinematic contrast of his life right here. I mean, going from having a locked psychiatric hold placed on you at 16 to facing this terrifying realization after a massive July 4th street brawl in your early 20s, he suddenly realized the excuses were running out. It just wasn't cute anymore. If he didn't change right then and there, he was going to end up a ward of the state, dead, or incarcerated. Part 2. The Science of Extreme Focus. It was sheer, raw survival instinct that drove him to completely rewire his physical brain. He quit partying, moved into a tiny studio, and literally locked himself in a chair to study, practically forcing his brain to change its structure. So, the crucial point here is neuroplasticity. You know, a lot of us kind of think our brains harden up like wet concrete after childhood, but neuroplasticity proves that the adult brain is actually highly malleable. But, and this is a big but, only if you apply the exact right biological formula. Huberman didn't have some special innate genius. He just accidentally stumbled onto the precise neurochemical recipe required to rewire an adult nervous system. He didn't use magic. He used a massive sense of urgency. See, when you intensely focus on a difficult task, your brain releases norepinephrine, which is basically adrenaline, and that causes agitation and alertness. Then it releases acetylcholine, which acts like a spotlight, marking those specific active neurons for change. But here is the secret sauce. The actual rewiring doesn't happen while you're stressed out at your desk. It gets locked in later, during deep rest and sleep. Now, what's really fascinating about this, and maybe a little counterintuitive, is that the brain actually doesn't care if you're acting out of love or fear. People always think learning is supposed to feel like this beautiful, effortless flow state. Actually, scratch that. It's the exact opposite. The intense stress and agitation you feel when trying to learn something hard is a required biological gate you absolutely must pass through. For Huberman, the sheer terror of ruining his life provided the urgency he needed to flood his brain with those necessary chemicals. Which brings us to part 3, dopamine and internal rewards. This is the ultimate fuel source for sustaining these new, really difficult behaviors. Because let's face it, running on adrenaline alone is going to lead to burnout pretty fast. You need something to keep the engine running long term. Okay, let's clear up a massive misconception right now. Dopamine is not just some reward you get for feeling good when you cross the finish line of a huge goal. In neuroscience, dopamine's primary function is to suppress the chemical that makes you want to quit, right? Every time you exert effort, a sort of quit counter of adrenaline builds up in your system. Dopamine swoops in, pushes that adrenaline back down, and literally gives you the physical energy and permission to take another step. And because of that anti-quit function, you must never, ever attach your dopamine to external validation. If you only feel good when you get likes, money, or praise, you are completely handing over control of your biological drive to the outside world. But if you can learn to self-reward the grueling effort process itself, telling yourself, I am on the right path, I am doing the hard thing, you generate your own dopamine. You essentially create an infinite internal energy source. It's a real game changer. So how do you take control of this system? You do it by mentally micro-slicing your tasks into duration, path, and outcome, just like special operations soldiers do during their grueling selection processes. They aren't focusing on a finish line that's miles away. No way. They focus on making it to the next meal or even just the next lamp post. By shrinking your duration, path, and outcome, and rewarding those tiny micro-wins, you continuously hack your dopamine system to prevent yourself from quitting. Moving right along to part 4, why mood follows action. Okay, we've talked a lot about how to focus, but what about when you are just frozen with fear, or you completely lack the motivation to even start? You might think, well, I just need to calm my thoughts down before I can act, right? We sit around trying to psych ourselves up, trying to find that perfect mindset, just waiting until we finally feel ready to tackle a tough task. But clinical science points to the exact opposite approach. Here is a core philosophy you can take away right now. You absolutely cannot negotiate with your feelings. Trying to control the mind with the mind is incredibly difficult, almost impossible sometimes. Instead, you have to use physical behavior to drag your mind into a new state. Action is literally the control panel for your feelings, your perceptions, and your thoughts. Behavior first, thoughts follow. Huberman actually witnessed this firsthand when extreme athlete David Goggins visited his Stanford lab. They used this crazy virtual reality system to study fear. And the moment Goggins explicitly identified his fear of the VR Shark Tank, he immediately volunteered to go first. He didn't sit around meditating or trying to calm his anxiety. He immediately used forward behavior to force his brain into a new state. Goggins instinctively knows what biology proves. There was this landmark Nature paper showing that moving forward in the face of severe stress is actually the absolute highest state of agitation. But doing so activates the dopamine circuitry. It physically rewires the brain for future courage. So the next time you're afraid, remember that moving forward, even if it's just taking one tiny physical step, changes your neurochemistry immediately. All right, part 5, the power of deep rest. Because remember, that intense focus we discussed, that only marks the neurons. It's during deep rest that your adult brain actually undergoes that physical neuroplastic rewiring. If you are always on, you are never actually changing.
And here is an absolutely wild, real-time biological hack. Your eyes are literally 2 pieces of your brain pushed outside your skull. When you stare intensely at a screen or a book in focal vision, you are actively triggering your alertness circuit. But if you simply dilate your gaze to a panoramic view, looking out at the horizon or just taking in the corners of the room, you immediately shut off that adrenaline system and broaden your perception of time.
And the absolute best part is that you don't need to book an expensive, week-long wellness retreat to recover. You can use real-time biological tools right sitting at your desk. You can use the physiological sigh, which is 2 quick inhales through the nose, followed by 1 long exhale through the mouth, to instantly drop your heart rate. You can go for a walk to generate optic flow, physically quieting the threat detection center of your brain. Or you can use deep relaxation scripts like Yoga Nidra to perfectly blend rest and neuroplastic rewiring. We've seen exactly how Dr. Andrew Huberman leveraged the biological friction of agitation, the internal rewards of dopamine, and the incredible physical power of action to rewire his brain from a feral teenager into a Stanford scientist. And guess what? The biology is exactly the same inside you. So I leave you with this. The next time you feel totally paralyzed by a challenge, instead of trying to just think your way out of it, what forward physical action will you take to trigger your own neuroplasticity today?